In this video, you are going to learn vertex and axis of symmetry of quadratics, and this is going to focus on pages 38 to 45 of your notebook. So if you want to have your notebook out and ready to go to follow along, I'm going to go over specifically pages 38 to 40 because those are the notes that I would normally teach in class. I will also record the You Try problems, but I am not going to record the homework, the practice problems in the book. I would like for you to try those on your own, and then you can check the key that I will post on Canvas. So for Chapter 9, Part 2, I'm going to talk about how to start interpreting the function based on the values that you have of your quadratic. So vertex and axis of symmetry, it starts off within the notebook, just kind of 5 key points. And it says for your steps here, number 1, what you need to do is make sure that your function is in standard form. And standard form just means that your function is going to have its first term be the square term, the second term is going to be the linear term, and then the last term is going to be the constant. After you have standard form, you will need to identify your A, B's, and C's, just like we did for quadratic formula. And the C value is going to be every time the point, the y-intercept point, so 0, C, the y-intercept of your graph. So that's where it's going to cross that y-axis. Number 3 says that your vertex will have an x-coordinate of x equals opposite sign of the b from your function. So whatever you put for that b value here, you're going to use the opposite sign here. So if you had been given positive, use negative. If you had been given negative, use positive, and then divide by 2a. This will also be the equation for the axis of symmetry, and what that means is your parabola is going to reflect kind of a middle vertical line where your function looks the same on the left to the right of that middle line. And as we start graphing, I'll actually graph that and show you what that looks like. For number 4, the axis of symmetry we will write as that vertical line. It does split your parabola in half perfectly. And then number 5, whatever value you got here from that formula, plug it into your quadratic and you'll get the y-coordinate of your vertex. Now, I apologize for kind of the scratches I recorded earlier and then realized that I couldn't see what I was recording, so I'm going to start this one over. So looking at these two functions, I'm going to just kind of briefly discuss the difference between when you have 3 numbers given versus in this equation you're actually missing a number. And so what I want to do is talk about finding the values of your vertex and axis of symmetry based on different functions. So as I look at this function, the first thing that I want to do is check that I have standard form. So as I'm looking at my function, do I have my square term first, my linear term second, my constant next? And the answer is yes. So that part has been met. For number 2, what I need to do is identify my A and my B and my C values. Here, A is the number -2. B is the number 4, positive 4, and C is the number -9. So those are those 3 values that we are given. The y-intercept that we set up here is going to be that C value. So I'm going to write down here that my y-intercept is going to be the point 0, -9. Step number 3 from up above says that we're going to use this formula, the x-coordinate of our vertex, opposite b over 2a. So if I have the x set equal to opposite b and then divided by 2a, I'm going to have from my a, b's, and c's here, opposite sign of this positive 4 will be -4. And then if we divide by 2 times my a value, which was -2, I'm going to get -4 divided by -4. And this is going to equal +1. This value is important for 2 reasons. First, it's the x-coordinate of the vertex, so now we know half of it. And then second, it is your axis of symmetry. So number 4, I'm actually going to write down what that axis of symmetry is. And I call that my abbreviated AOS, axis of symmetry, is x is equal to 1. And now what I'm going to do for step number 5 is plug in the value that we found for x. So that number 1, we're going to plug 1 into each x of our function and solve for y, and then we can have the entire vertex of our function. So as I plug this in, I'm going to have y equals -2, and then in parentheses I'm going to plug in this 1 squared, plus 4 times the x value, again substitute 1, and then -9. So notice I'm plugging it in to every x that the function has. With your order of operations, you need to do your square first. 1 times 1 is 1, and 4 times 1 is just 4. And now I can multiply here in the front. -2 times 1 is -2, and -2 plus 4 is going to be +2, and +2 minus 9 is -7. So now I know the x value of my vertex and now the y value of my vertex. So my point, the vertex, is going to be the x value of +1 that we found here and y value of -7. So there's the vertex point. My y-intercept I labeled up here, that's the c value of the function. So that's the point 0, -9. And my axis of symmetry I wrote down here. It's a vertical equation. So we used, back when we were graphing lines, the phrase hoi vux. And our vertical line uses an x equals equation. So our vertical line that cuts our parabola in half is an x equals 1 equation. So down here for AOS, x is equal to 1. Now I'm going to answer these two questions, which I haven't quite addressed yet, but I'll do that with our function here. All you need to do is look at your lead term. Now my lead term is a -2x squared. If your a is negative, your graph is going to open downward like this. If your a is negative, which means that your vertex is going to be the highest point on your picture, which means your vertex is going to be the maximum point. So there will be no other point that goes higher than that vertex point. So that's why we call it a max. All the other points go below it, so the vertex is the highest point, the max. And if your a is negative, it's going to open downward, and so I'm going to put the word down here. Now I'm going to show you this same process, but with a new function, and notice that this function is missing the linear term, the middle term. So for step number 1, again, what I'm going to start with is standard form. Do I have my x squared term, a linear term, and a number term? Well, technically it's not written, but it would be 1x squared plus no x middle term and then -10. So if you want to see all three pieces, that's what it would look like. The 1 in the front is really unnecessary, but it's represented here because you have an x squared. So for number 2, my a here is 1, my b is 0, and my c is -10. Now step number 3 says to identify my vertex, and I'm going to start with that formula opposite b over 2a. The opposite sign of my b is 0. Well, 0 isn't positive or negative, so I just need to use the 0 number. And on the bottom of my fraction, 2 times my a of 1, 0 divided by anything is 0. So the x value of my vertex is 0, but also my axis of symmetry is x equals 0. Then step number 5, what I'm going to do is plug in the number 0 into the x of my function. So my function was y equals x squared minus 10. I'm now going to plug in 0 for the x. So I'm going to take 0 and square it and then subtract 10. Well, 0 times 0 is 0. And if I subtract 10, I get -10. So my vertex will be the x value of 0, a y value of -10. My y-intercept, I didn't label it this time, but it is the c value. So my y-intercept value is going to be this -10. 0, -10. These happen to be the same thing, which means your vertex and your y-intercept happen to be the same point. And then your axis of symmetry here was step number 4. It's the equation x equals 0. Now for this question, look at your lead term, your 1x squared. So if I have positive 1x squared, my a is a positive, which means my graph is going to open upwards like this, which means the vertex on my graph will reach down and then my graph will continue to go back up from there. So my vertex in this picture will be the lowest point, which is called a minimum. If your graph opens up, your vertex is going to be the lowest point on the graph. That wraps up our page 38, and now I'm going to start at the top of page 39. Now at the top of page 39, it says, for example 2, for each graph, determine the vertex, the state if it is max or min, whether your vertex is that high or low, and then find and draw the axis of symmetry. And I said I would point that out in the graph, and I'll do that here. Then what we're going to do is find the solutions for each of the graph. Now I want you to highlight that word solutions because there are many names for solutions, and I hope you remember from our last unit what those would be. But our solutions are called x-intercepts. They're also called roots, and they are also called zeros. So make sure that you recognize that solutions mean those same things. So as I'm looking at example 3 in the picture here, I want to look at the point that is my vertex. So the point that's either the lowest or the highest on the graph. Can you identify that point as an ordered pair? This is 1, -1. Now looking at my picture, this is the lowest point on the graph, so I'm going to circle minimum, and that means it opens upward from there, so these two sides go up. My axis of symmetry is the vertical line that would cut your picture in half, and if I go right through that vertex, this vertical line would match the x value of your vertex. So this vertical line is going to be a vux, a vertical line, and it goes through the x value of 1. Now solutions are also called x-intercepts, roots, or zeros, and we do have a couple solutions. Here's one and here's one. One of them is at 0 and another one at 2. You could label these as ordered pairs, but I'm going to save time by just listing 0, 2. Now in the next picture, I'm going to do the same format. The vertex on this picture over here is the highest point on the graph, and I'm going to label that point. It's left 1 up 4, so -1, 4. This is the highest point on the graph, which is called a maximum, and our graph from our vertex opens downward. Now my axis of symmetry is going to be the vertical line that will cut my parabola exactly in half. So as you're drawing that line, look and see what number you cross on your x-axis. The x of your vertex and the vertical line here should have the same value. X is equal to that -1. Now your roots, remember I said there were other names that you could call your solutions. Your intercepts here are +1 and -3. So I'm going to say x equals -3, 1. Now the order of which you put those really doesn't matter. I tend to do the least and then the greatest, kind of in order, lowest to highest. But really technically the order doesn't matter. All right, now same techniques, but now 2 new graphs. For number 5, as I'm looking at my picture, I can point out my vertex right away. My vertex is on the x-axis, and this point is the point -1, 0. This is the highest point on that graph, so I'm going to hit maximum here. I'm going to circle that, and it goes down from there, so it opens down. My axis of symmetry is going to be the vertical line that crosses through that parabola and cuts it exactly in half. Now as you draw that line, look at what x value you cross. Should be the same as the x in your vertex. And then my zeros, same thing as x-intercepts, are 2 solutions. Oh, actually, look, this one only has 1. We have 1 intercept, and it's at -1. It's okay to have 1 intercept because here your maximum point is on the x-axis, which means you only have 1 intercept. Now number 6, this picture here, if you look closely, your x-axis is here and your y-axis is here. So something's going to change here. Notice the vertex here, the lowest point on that graph is the point 1, 4. This graph opens upward from here. So that means the point that we have is the lowest point on the graph, so minimum. The axis of symmetry is a vertical line that cuts your parabola in half. So notice what x value you cross, it should match the x value of your vertex. So that vertical line is x equals a number, and in this case it's 1. Now look at your x-axis. Do you see how your parabola does not touch this? That means you have no x-intercepts. There are none in this case because your graph does not touch the x-axis, so it cannot have x-intercepts because it doesn't touch it. Now, if you want to pause the video here and go right to the practice, if you feel like you're understanding this well, that's great. If you want to listen to the you try section, just kind of hear each of the examples one more time about finding your axis of symmetry and finding your vertex, and then kind of looking at it from the graph perspective, feel free to keep listening. It is our expectation that you do the practice problems in the notebook and then finish up with whatever assignment that your teacher has for this section. So I'm going to move on to the top of page 40 and I will go through the you try. Again, if you want to skip this and jump right to your practice problems in the notebook on pages 44 to 45, that would be okay. But the you try section, just in case you're needing a little bit more, you can go ahead and keep following along. I'm going to go through this section just like we did the very first couple examples from the notes. So those, oh shoot, I skipped page 40, didn't I? I'm so sorry. Let me go back. Page 40. Okay. Example number 7. Sketch a graph given the following information. Now, sketching the picture, what we're going to do is follow along with whatever the conditions are that your example has. For this one, it says sketch a parabola, and your roots, your x-intercepts are going to be at -3 and +6. So those are going to be my two x-intercept points. And then my vertex needs to be a maximum. Now if my vertex is a maximum, that means my parabola needs to open downward. So what I'm going to do is just draw a U shape that's going to connect through those 2 points. I'm not going to make it any more complicated than that. It doesn't tell me where my vertex is. I know it needs to be in the middle, but I don't know how high, and so I'm just going to draw a loop that will be centered between those 2 points. For number 8, it says sketch a graph of a parabola, and now in this case they tell you the vertex. So my vertex is going to be at -2, 4. So there's my vertex. I am given my solutions, also called x-intercepts. One of them is at 0 and one is at -4. If you can kind of tell, your parabola is kind of opening upward, or I'm sorry, opening downward from your vertex to those 2 points. So I'm just going to connect them with a smooth, curvy parabola. For number 9, sorry guys, I don't know why I missed page 40, but here it is. For number 9, show the quadratic equation given a root of 2, just one root at 2. And the vertex will be a minimum. Now if your graph has a minimum, that means it's going to open upward and your vertex is going to be the lowest point. Well, if you have only one x-intercept, then your vertex has to be that point. So I just want my parabola to open upward from here. It does not say how it opens up. It doesn't say the rate, if it's going up, you know, double the speed or half the speed. So I'm just going to draw a parabola opening up from that root of 2. Now number 10, our last problem, I promise, before the you try section. Sketch a graph of a parabola whose vertex is at this point -3, 6. So -3 up 6. So there's my vertex, and has no real solutions. Well, let's think about what that means. If it has no solutions, that also means it has no x-intercepts. How can you draw a parabola so that it will not touch the x-axis? Well, the easiest way would be to open upward above the x-axis so it never touches this line. If your graph opens downward, then eventually somewhere it's going to cross the x-axis, which means it will have x-intercepts. And so open up above the x-axis. Now, I sincerely apologize. I'm going to start the You Try section. Feel free to go work on your practice problems or do the assignment on Canvas, whatever your teacher has for you, if you feel ready to do that. But don't forget that you are still responsible to do your practice problems in your notebook. So on page 41, You Try, let's go through these 3 types of problems one more time, and then you can do your homework. So for my first example here, I'm going to go back and do the section that talked about identifying these 5 steps. I'm going to identify if I have standard form, my y-intercept, the x-coordinate of my vertex, which is also the same as my axis of symmetry, and then find the y value of my vertex. So I'm going to do those 5 steps here. So step number 1 is check for standard form. Do I have my x squared term, my linear term, and my number? Yes. So step number 2 then would be to identify my a. My a is 1x squared, my b is 4x, and my c is -1. My y-intercept is the c value, and you want to put it in the y spot because that's what makes it a y-intercept, and then the other number is 0. For step number 3, we're going to use the formula to find the x value of our vertex by using the formula opposite b over 2a. Opposite sign of my 4 is -4, and I'm going to divide by double my a, or 1. So in this case, -4 divided by 2, which is an x value for my vertex of -2. This also happens to be my axis of symmetry. And now I'm going to plug that number in for number 5. Y is equal to, if I plug in now -2 into each x of my function, let's see here, -2 in parentheses squared. Make sure you have parentheses, otherwise your calculator will not give you the right answer. So -2 times -2 is 4. 4 times -2 is -8, and then we're going to subtract 1 more. 4 minus 8 is -4, minus 1 more is -5. Now let's put these pieces together. My vertex has an x value of -2 and a y value of -5. My y-intercept I already labeled from my c value here is 0, -1. And my axis of symmetry should match the x of my vertex. It's the number -2. And it's an equation, x equals -2. It will always be x equals because it will always be a vertical line. Now, how you determine if you have a max or a min is based on whether your lead is positive or negative. Now, if I have a positive x squared, that means my graph is going to open upward, which means your vertex should be the lowest point on the graph. That's called a minimum. For number 12 here, I'm going to do the same 5 steps. I do have standard form here. I have my square term, then my linear term, then my constant. For 2, my a is equal to -2, b is equal to 8, and c is equal to -8. For number, before I do that, I'm going to identify my y-intercept. Y-intercept is the c value, and that needs to go in the y value of your point. The x is going to be 0. Now for step 3, I'm going to use the formula to find my axis of symmetry and then use that as the x of my vertex. So opposite b over 2a. My b is positive, so opposite of that is going to be -8. 2 times my a of negative 2 is going to be negative 8 divided by negative 4, which is going to end up being positive 2. So my axis of symmetry is the equation x equals 2. Number 5, I'm going to find the y value of my vertex by plugging 2 into the equation. So I'm going to take negative 2 times my x of 2, square it, plus 8 times 2, and then minus 8. 2 squared is 4, and then you can multiply by negative 2. So PEMDAS rules say you have to do your exponent before you multiply. Then we're going to add 16 and then subtract 8. Negative 2 times 4 is negative 8, plus 16 and then minus 8. This is going to end up being 0. So my vertex is 2, 0, so my x and my y. My axis of symmetry is that x equals 2. And my y-intercept I labeled up here, it's 0, negative 8. If my a value is negative, that means my graph is going to open downward. That a determines how your graph opens up or down, up for positive, down for negative a. And then that means that my picture will have a high point on the graph called a maximum vertex, and that means it opens down. We're almost done. Hang in there. You guys are doing really great. For each of the 2 graphs here, I'm going to identify these pieces located that are listed down here, located on the picture that I see. So as I am looking at this parabola, I'm going to label my vertex. It is at negative 2, negative 1. My axis of symmetry should have the same x value, and this graph opens up. The vertex is the lowest point on the graph, which is a min. Now my zeros are called my x-intercepts, and there are 2 of them. I have 2 x-intercepts, an x-intercept of negative 3, and an x-intercept of negative 1. In the next picture to the right, number 14, I have a vertex that is located at negative 1, 1. This graph is opening down, which means I have a maximum for my vertex. The vertical line that cuts my picture exactly in half, now I didn't draw it over here, but I can, should have the same x value of my vertex, so negative 1. And my zeros, also known as my x-intercepts or roots or solutions, we have 2 of them here. They are x-intercepts of negative 2 and 0. All right, we have 2 more pictures and we are nearly there. Oh, no, we have 4 more. Here we go. In this picture at the top of page 42, it says, what is the vertex here? Now that point is actually already labeled. Can you tell me what this is? This point would be the point, negative 1, 2. This graph opens up, which means it has a minimum. The axis of symmetry is that vertical line that cuts your graph in half. And that vertical line crosses an x value of negative 1. Now my zeros, I have no x-intercepts here. There are none because our parabola never touches that x-axis. So we'll just write the word none. In this picture over here, number 16, my vertex is at the point 3, 0. My graph opens up, which means my vertex is the lowest point. My axis of symmetry that cuts my picture in half crosses through an x value of 3. Now my zeros, my x-intercepts, there's only 1, and it's at 3. Now I have 1 section left, and that's to draw the parabola. So at the bottom of page 42, can you sketch a quadratic that would meet these conditions? It would have no real solutions, no real roots, so it means it does not cross the x-axis. And then it needs to have a vertex at the point 2, 3. So at 2, 3, I'm going to draw my vertex. And this means do not cross x-axis. So make sure that your parabola opens up instead. For number 18, sketch a quadratic equation with roots. This means x-intercepts of -8 and 0. So here's -8, here's 0, and we'll have a minimum. This means your graph should open up. So draw a parabola that's centered through those 2 points. Axis of symmetry should be right in the middle, so -4. Just make it look symmetrical about those 2 x-intercepts. And then last 2 of the U trisection before the practice starts on page 44. These 2 questions here. So again, I'm at the top of page 43 now, the last of the U tri section before the homework in the book. Sketch a graph of a quadratic whose vertex is at the point 6, -9. Now 6, -9 is going to be here. And they want you to give x-intercepts of 3 and 9. Here's 3 and here's 9. Connect those points with a smooth, curvy parabola, and you drew your picture. Number 20, the very last one. Sketch the graph of a quadratic whose vertex is at the point 7, 6, 7, 6, and has 2 roots. That means it will cross the x-axis twice. So I want to make sure that however my parabola opens up, it should cross 2 times. Now if you follow that pattern, if we go over 1, down 1, over 2, down 4, so over 2, down 4, 2 squared, 1, 2, 3, 4. And then over 3, down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can actually draw a proper parabola with the normal pattern we typically have. So I'm just going to draw that one like that. I hope that this lesson made sense to you. If you have any questions, please do not hesitate to reach out to your teacher. I know they will be super happy to help you. And I hope you're well, I hope you're safe, and I hope you're going to have a great rest of your day.